Sources inject light into the simulation region. The fields from the source are injected as a pulse over time, which propagates through the simulation volume and interacts with surrounding structures. A source pulse can be seen propagating through a straight waveguide in the movie here. By default, the source pulse shape is automatically generated based on the specified frequency or wavelength range of the source. You may recall that the source pulse and normalization were covered previously in the CW normalization section of this course. CW, or continuous wave normalization, is used for linear systems to obtain the frequency response as though the spectrum of the source is uniform. In the example on this slide, a plane wave source is injected into free space, and a monitor in front of the source measures the net power transmission. Since the light is injected into free space, 100% of the light will pass through the monitor. With no normalization applied, the transmission spectrum from the monitor, shown by the blue line in the plot, shows the shape of the spectrum of the source pulse. With CW normalization applied, the transmission spectrum, shown by the green line in the plot, is 1 over the frequency range. As you can see, the spectrum is uniform when the CW normalization is applied. If you want to review the normalization method in more detail, you can refer back to the CW normalization section of this course, or view the knowledge base resources linked below. Different types of sources are available in FDTD solutions to represent different field profiles. The available sources are listed here and include the plane wave source, Gaussian beam, dipole, mode, total field scatter field, as well as an import source to specify a custom field profile. We'll go into the specifics of each source in later units. The type of source to choose for a given simulation will depend on the experimental setup that you want to replicate, or the result that you want to measure from the simulation. For example, a laser source, which has a Gaussian beam profile used in an experiment, can be represented by a Gaussian source. A point source can be represented using dipole sources, and the supported mode of a waveguide or fiber can be injected using a mode source. In the online knowledge base at lumerical.com, you can find supplementary information about the sources, including the definitions of each of the source settings, under the Component Tools Reference Guide, Sources chapter.